Krish. Yeah, Krish, get in. You press number 1 for edit. You're not getting a calculator now. Just sit down and behave. All right. You're under L1. We're going to enter in some independent data. I believe they were years starting in 95. Originally, you tell me. Originally, you guys entered in data with 1995 and so on and so forth, and you got an overflow error. And the reason you got the overflow error is because what? Why? Mathematically, why is that a problem? Why can't the calculator handle it? Be more specific. Too much numbers? Too many numbers? That's a bunch of crap. Anybody else? Are we good? Yanjun, we're good?
Yeah.
Yes. Too many numbers? This is the sad.
Oh, sir.
Yes, sir.
It needs to be calculated up to that 1995 number, therefore putting that all together.
Oh, come on, people. Think math, man. Like actual math. Like visualize the function. Yeah. No. He put his hand up.
Well, I was going to say that because the numbers are so large that they can't sufficiently store it, and also that it'll be all the way over there. You're starting at 0, so that's starting at 99. You won't be able to see it.
Nonsense.
The specific year has nothing to do with
Nonsense.
About the window.
What's the form of, what type of function were we modeling?
Exponential.
Y is equal to, I think they wrote it as a times the base to the x, right? So your x value is going to be 1995, 1996, 1999. Now, in order for that to work out with such a massive exponent, what does that mean the base is going to have to be in the model? Like an atom. It's going to be the smallest bloody number you can think of, right?
Yeah, I have the.
Because the dependent and the independent data are fixed, right? There are only 2 parameters that can change in their exponential model. The A value and the base, right? So if the exponent is going to be so massive and your Y values have to go with your X values, then the only way to combat that, to make those match, is either to have the coefficient teensy weensy and or the base teensy, especially the base, because the base is raised to an exponent. So like, I don't know, maybe the base would have to be like 0.3001, which the calculator cannot deal with. Do you guys follow that? Anyhow, so who's found the question?
It is page 194.
Page 194.
Question 9.
Question number 9. Ken, what's the first year? 1995? I think I went with 5, right? So do I just keep on going?
6, 7, 8, 9, 10, 11.
No. 11?
Yeah.
Okay. Can somebody give me the dependent information? Wait a minute. Okay, dependent?
100.
100.
130.
130.
170.
170.
220.
220.
285.
285.
375.
375?
Yeah. And 490.
490.
Page 194.
That doesn't look like 490.
Doesn't work.
Don't die on me now, machine.
So you
Oh,
start.
you son.
You stale.
What?
You stale.
You stay.
DL. Oh,
Delete. No, it's sticking.
Yeah.
Are you kidding me? It's been giving me problems.
So use the left side.
I did. I gotta go again. It's frozen.
Oh, go.
Oh, shame on you, Eric. Eric, wake up, man. We already said 184. Come on. Let's see if I can save this. John, I'm getting out of here. I gotta go back. Yeah, I'm going to clear my memory here. I'm going to try and clear the memory. My calculator no longer works.
Sure, I think it's
What happened to my machine?
mine works well.
Reset calendar.
Reset.
I did that before. Can you give me the same trouble? Okay, 5, 6, 7, 8, 9. No. 9. 10. Is there more than 10? I didn't.
You did.
I didn't. Go. Let's hear it.
100?
Faster.
131, 71,
Okay, that was too fast. 130?
170, 220, 285.
170. 220. 285.
Faster.
375. 490.
Okay. So I need to, what was part A asking us to do?
So what? Which page?
Don't ask me. Ask somebody else. We discuss this.
Terminal equation.
Determinant equation. Do they specify in the question that, do they tell us that it has to be exponential?
Exponential.
Okay, before I do that, I have to, well, I want to make the plot feature work. So, I'm already good, L1, L2. I've got to turn the diagnostic feature on. Where the hell is it?
100.
Catalog? Oh no. Oh no, don't you dare. Oh my god, you're sticking on.
Just press D, sir.
I'm not, I'm too tired to press that green button. Diagnostic on, I know, but. Alright. So,
yeah, you just go back and
zoom, 9. Let's see. Oh, that's just beautiful. That's just so beautiful.
exponential.
Did I turn it on? Turning it on would have been good.
So yeah, so you do this one, right?
Yeah.
Right there.
Yeah,
And then
Okay, we got that, right?
or you press there.
Okay, you press second function.
So I don't think that.
Look at the screen and you see the, you see where it says catalog there over the 0? And then you remember now?
So here, so it should be that.
Okay, so we get our little graph here, right? They want the equation. So to get the equation, we press the stat button. I didn't, what stat? I said stat.
This is stat.
What are you talking about? You guys don't know that. It's too early for you guys. So as I said, you press the stat button. What are you talking about? I think you guys need some more sleep. And you scroll down. You scroll down until you see. Why don't I have it as an object? Exponential regression. And I know that our stuff is already set to default L1, L2, but let's do it and let's do the save thing. So we'll go L1, comma, L2,
Just second.
comma, vars, scroll over,
Quick.
press 1 for function, and pick 1, and hit enter.
Second.
And beautifully, we have an equation that reads something like y is equal to 26.6 times 1.3-ish to the x, with pretty much 100% correlation.
Can you go over the step again from getting to the graph to the equation?
Getting from the graph to the equation. So you have a graph, right? Now, you are told to pick exponential, so that makes your life easy. You press the stat button. You press the stat button. You scroll over to count. Scroll down until you find exponential regression. For me, it's option 0. Hit enter. Now tell it where the independent data and dependent data is, and tell it where to save the equation. So independent data is L1. comma, dependent data, L2, comma, VARS bars. Scroll over to Y bars, pick option 1 for function, and save it wherever you like. I'm going to put it in the first function slot, and then hit enter.
So I have a question.
You got it?
Is it make any difference if I say exponential regression L2 L1?
Yes! Of course. What have we been talking about? Did you hear Ken's question? No, of course Milad wants to hear it because he knows it's a screw up, so he wants to make, no, I'm sorry, I didn't hear that. Could you repeat it so that I can make fun of him? That's what you meant, right? Ken asked if it makes a difference if you type in exponential regression L2, comma L1. He's saying there's no difference. Is there a difference?
I did.
Because it's the regression model, independent, comma, dependent. So if you flip it, it's going to give you the inverse function. And the inverse of an exponential function is a, yeah, logarithmic function.
Sir?
What?
So when we say L1, L2, L1 is going to be the actual y.
The x, independent.
And L2 is going to be the
I mean, it might not be the x, it might be the time and the, you know, the independent data, comma, the dependent. And yes, typically in math books, x is allocated as independent and y is dependent. Okay? So, what's part B?
Suppose that 100 million of it are.
Okay, that wasn't English. I actually need, that was not from, I just heard, suppose that let him read, let the man read. Go, read again, loud.
Suppose that 100 mil of arcanid and prey.
Okay, I gotta read this. I'll read it. It's alright. It's alright, I'll read it. Okay, it's here. The following table shows the estimated population of a crop destroying insect. Blah blah blah, we did part A. Suppose that 100 million, oh by the way, make sure you realize that our data that we put in is not 100, it's 100 billion, so it's in the billions, right? Suppose that 100 million, so our data is like 100 times 10 to the 9. Now they're saying suppose that 100 times 10 to the 6, well actually, if we put it in as 100, then that means if we're putting in, so 100 million is going to be 1,000th of that, which would be 0.1, right?
Yes.
Anyways, suppose that 100 million or 0.1 billion of an arachnid that preys on the insect are imported from overseas in 1995. So do you guys understand that the dependent data right here, do you guys understand that this data in this column is the quote-unquote insect? And now apparently, that's the insect over here. The population of the insect is a function of time. And now apparently this thing called an arachnid in 1995 was brought in at 0.1 billion or 100 million. And apparently it eats these guys up here. Assuming that the arachnid population doubles every year, estimate when it would equal 10% of the insect population. I would really love to just draw. So let's see if I can cheat without going to the board.
I want to put pages instead.
Oh, come on, Word.
2010.
Come here and restart.
Probably toward the.
That was this.
Insert something or you have to
Okay, let's find a drawing.
I want to put
Oh, come on, where's
bracket
drawing?
here between this equal.
I'm gonna try going to page.
Oh, I think you do insert.
Okay, so I repeat, the question is, estimate when this arachnid population will be 10% of the insect population. Where have we saved the insect populations formula? Under what?
L2.
Y1.
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 Oh, the formula.
So the arachnid, so we wanted to, so if the arachnid, oh come on.
Just go to page.
Go to paint, yes, paint.
Good job, Ahmed.
Computer's what? Why is my computer gonna restart?
You have to do that. Postpone, restart now.
You can postpone it.
Stop now.
Oh, yeah, I still remember.
Start now.
Alright, where is this thing? Where's paint?
And accessories.
Accessories.
So you don't know where it's pen?
Yeah, I would have found. Guys, I'm on 3 hours sleep. I would have found it. Okay, now, help me. What do I want? This one?
Pick a pencil.
Alright, I got a pencil.
You got it.
So we start off with 100 million of this arachnid, and it doubles every year. So if you had to do an equation for the arachnid population in the billions, we would say that A, now do you understand why I'm going to make it in the billions?
Yes.
They gave it to us in millions, but why am I going to make it in billions?
Because the population is involved.
Because the population of the insect is in billion. So this is also exponential because they say it doubles every year, right?
Yeah.
Agreed? So we're going to say that A is equal to its initial population, which is 100 million, which is the same thing as 0.
So why don't you just type it in?
Oh, how do I make, can I make the thickness of the line bigger?
Yes. Size. It's size. Right.
Yeah.
Why don't you just type it in?
No, because, there we go. 0.1 billion, right? Now it doubles. Agreed?
Square.
So what, not squared. So your base is going to be?
2.
If it tripled, what would your base have been? If it halved, what would your base have been?
5.
Nice. Now, it said it doubled every year, but here's the thing. We are going to make this thing equal to the other thing. And the other thing's time, the other equation's independent data is in years starting at 1995, but the initial time is a 5, correct?
Yeah.
So we need to make this thing,
I think to a power of x.
yeah?
To the power of x.
Yeah, I think you're right.
Sir, nobody on the board will be a lot easier.
No, it's not. I'm thinking. I'm taking time because I'm thinking. So if we let this thing be x or we let it be time, does that make sense?
No.
Yeah, no, it does because no, it does not. Because when you put it, you're right. At your initial value, you want this thing to work out to being 0. So, which means that you want this thing to work out to being 0.1, which means you need this to be 1, right? So this should be t minus 5.
Yeah.
Oh, yeah.
Agreed?
Yeah.
Who would like me to explain why? Again. Okay. Our start time is 1995. Okay? Our start time is 1995.
Excuse the interruption. This morning, the photographer is going to be taking photo retakes for those students who missed photo day. And if right now, could the grade 9s and 10s who missed their photos please go down to the library?
All right, we good? Now listen. Look, our initial year is 1995, and in the other equation, though, we didn't put it in as 1995. We put it in as a 5, right? So, 5 is our start time. What is the initial population of this arachnid thing? 0.1 billion, agreed? So that means when you enter your initial time, which is 5, which corresponds to 1995, this arachnid population should just give you 0.1, right? So by putting a minus 5 here, what happens when you replace t with a 5? You have 5 minus 5, which is 0. What is 2 to the 0? 1. And then 1 times 0.1 is 0.1. So that is the correct equation. But now what they're saying, what they want is they want us to figure out when, meaning time, when 0.10, when 10%, right, of the arachnid population equals the insect population. Correct?
No.
Shoot. Really?
Just
Now I gotta go
replace-
back and erase
no,
them.
just replace the A with I.
Yeah, I know, but
You can just erase.
when 10% of the insect population
He's just taking his time.
equals the arachnid, he's just taking his time. Why?
Nothing.
Oh,
And
you don't
by
want to.
yourself.
You don't want to stand by your remarks? I actually don't want to get up. Okay, so we have 0.10 times I is equal to A. Well, what is I? Well, we don't even have to write down what I is because we've saved it as Y1. So we can just say 0.10, which is 10% of Y1 equals A. But but we can program A as Y2 and just type this in as Y2. Agreed?
And then we just check when they meet up.
Actually, you know what I'd rather do?
What?
I would rather do this. Bless you. I'm just thinking because of the calculator, maybe a better thing to do is this. How do I undo, how do I?
Erase.
Yeah.
It's erase.
Control Z, right?
Yeah, I'm gonna do.
Let's call 0.10 Y1 Y2, right? Let's call that Y2. And I'll show you how to do that very easily. And we're going to call this, what do you think I'm going to call this? Y? Nope. 3.
4.
Yeah.
So now, let's go to the calculator. You guys see what I'm doing? Okay, so let's go to the calculator. Let's press Y equals. Oh boy, where's my machine? I hope that was just default. Oh. Press Y equals. Let's go to Y2 and then let's make it, as I wrote down here, 10% times Y1. So you can go 0.1 times, and now you have to access Y1. So I think you have to press VARS, Y bars 1, and then 1, and then hit enter. Okay. And now I have to program Y3 as A, right? I'm not saying this is the only way you have to do this. This is just what came to my very sleepy mind. So A itself is 0.1 times, where's the multiplication thing? Times, I don't think I need brackets, 2 to the exponent, this is an exponent, open bracket, shoot. I have a question. Do we just put in X?
Yes.
No, L1. L1 minus 5. L1 minus 5.
If you want
L1
to just
is
put in
the
X
X
minus
value.
5, that just makes it clear.
No, but,
L1 is the...
no, but that's the data.
Yeah, I think so.
But Y1 has an X in it. Look, Y1 has an X in it. Actually, look up here. Y1 has an X in it. So we wanted to recognize, it's apples to apples, right? So I can put in an X. But where the hell is X?
SDO at the bottom segment.
Alpha, then SDO.
Oh, right there?
Yeah, but you have
Beside
to-
the
Yeah, no, I got you. So press the green button.
And then beside the 1.
Nice. Minus 5, yeah? Do you guys understand why I can use X? Because look, Y1 is using X, right? And we've already created Y2 as 10.1 times Y1, and we're making our X the same X. They're both time, right? Where T starts at 5, right? It means 99.5. Okay, now all we got to do is we got to do the, I'm going to turn this one off. I'm going to turn this one off. I don't need that one on, agreed? And I'm going to press graph and cross my fingers. That's just beautiful. I don't see anything.
Zoom out.
Yeah, zoom out.
Okay, and the other thing, oh, there it is. And the other thing is, I don't need these things, do I?
No.
I'm going to take them out of there. I don't want to see them. That was terrible. So I'm going to go into here and turn it off. Now I'm going to go back to graph. Now here's the thing. When I'm trying to graph our equation, so I can't just go zoom stat, because if I go zoom stat, it only works for data points. These are equations. So now I basically got to start playing some games with the window. So I'm gonna press zoom and I'm gonna go, I don't know, let's try the zoom out feature. I don't know what that means. So I'm gonna just do this. I'm gonna go straight to the window. Well, what's my minimum value of x? 5, right? Agreed? So I'll put in like a 4. What's my maximum value of x? Hang on, let me do 4
So
hours.
you just need to zoom
Can
out
I finish?
once.
You're gonna show us the zoom out feature?
Yeah, you just press enter. You press zoom out, you press enter, zooms out and you can see the intersection.
But it had a criteria there.
No, it doesn't work.
Okay, I'll go with your idea for that. So zoom, if I go to zoom out, it's got some,
You see a little bit.
No, wait, it's
You have to load the graph.
no, it's thinking about it. Okay, I'm gonna do my thing.
And then press enter. Just press enter once.
I did press enter.
No,
Yeah, the graph is still
it's not.
loaded.
And now press enter once.
Okay, so but what does this mean? There's a little star here.
Yeah, that's your
Just press
point.
enter.
Just press enter once. That's the point. That's the middle point. It's gonna zoom
Yeah.
out to that point.
But there's nothing there.
Zoom out, sir.
Yeah, I'm telling you. Just press enter. That's
Okay, but what? I don't understand how it worked. I need to know what's going on. And this is ugly. Oh no, actually, that's pretty good.
Shit, but mine doesn't work.
I don't know how that worked. And where's my other line?
It's
Oh.
coming.
But I don't understand what the criteria.
There was no criteria. That's just where your x and y is.
But why is it giving me a 7, 8, and 295?
That's
Your
where
point
your
is in
point
there.
was at.
Oh, that's where I was.
Yeah.
Oh, I see, I
And
see.
it's gonna zoom out. Consider
So
that.
could I move that point?
Yes.
Yes.
How, like this?
Left, right.
Oh, just move? Oh, I see. So you kind of hover over the area. So I would want to kind of hover over here now, right? I don't really need to.
But
Don't
if
you
you press
zoom in
enter,
on
it's
that?
gonna zoom out.
Yeah, but it's going to be zooming out. I wanted to zoom in. I want to zoom in now, right?
Zoom box, make your box.
Oh, yeah, zoom box. Zoom box
Or
is
you can
nice.
just do zoom in.
Let's do the zoom box.
Zoom in is better.
Because I don't know if it, so I'm going to go here, slide over to here, please. Work with me, machine.
It's 15 years.
Enter.
Just zoom in, it's much easier.
So you said 2010, yeah. Okay?
Sorry, I have a feeling the interested at
If I may,
we must go a little more left.
Every year.
let me just, what do we get here?
Like I said, zoom in is better. Got my-
Oh, no.
Okay. So this is what we're looking for here, yeah?
15 and 172.
The only thing,
About 50%.
okay. So second function,
Oh, interesting.
calc,
Oh, yeah.
option 5. It's asking me, is this the first equation that I want? Y2? Yup. Do I want it to intersect with Y3? Yup. Is that a good enough guess? I'm going to go closer to where the thing is. That's good enough for me. Enter. And
15.7.
apparently, that's 15.7. But remember, 15.7 is,
19,
hang on a
no,
second.
2005.
5, when x is,
2005.
Oh wait, yeah, x minus 5, so you have to subtract 5 from here.
Oh.
I'm thinking, yeah, you have to take away.
Calc, right? But it gives you like this.
Yeah, this thing starts, you just have to add, actually. All you gotta do is this. Well, I have a calculator right here, but whatever, I don't wanna touch that one. All you gotta do is recognize the fact that this information started at 1995, right? So I'm still thinking, so if it started at 1990, a 5 would have been 1995. This is a 15, so it's like 1995 plus 10.7, right?
So what about minus 5?
You see, because, yeah, 5 means 1995. This is the same thing as 10.7 blah 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 plus 5, right?
Oh.
So I'm just gonna add, does that make sense? I'm gonna add 10.7 to 1995. Do you guys know what I mean? I think, I'm sorry, I'm a little dopey here, but, okay. What does x equal 5 correspond to?
No, but the thing,
1995, right? So this thing is 10.7 above that, right?
Yeah.
So what's 10.7 plus 1995? It's 2005 plus a 0.7 of a year, right? which is over half. So it'll be sometime in 2005. Does that make sense?
Yeah, yeah.
Y. Y is the pop. So Y is the population 5. Its starting value is 5.
Oh, okay.
Right? So that means that your initial value is 5, which means 1995. So if I go back to my, where the hell was I? Where did it go? If I go back to this thing,
Minus 5 because
where is intersect?
5.
If I go back to this thing, I have an x value of 15.7. 15.7 is the same thing as 10 plus, sorry, it's the same thing as 10.7 plus 5. Agreed?
Yes.
In other words, just do 15.7, subtract 5, you get 10.7. That's the number of years you're going to add to the starting year of 1995. Agreed?
Yeah.
Naomi, do you follow that? No, I'm going to write it down. Here, I'll write it. Where,
因为你它是x等于5，
where the hell is my
其
thing?
实
Here. How do I clear the screen, guys?
然后就那什么，所以就加时。
I don't want.
算出了它那个日期的，它就算出了它日期的那个。
Where's the file option?
Control A delete. Oh, that
Yeah.
doesn't work now. Just paint. Paint is done.
Hang on. I'll just select it.
Oh, they actually work. Surprise.
Okay, so what does x come out to being there? 10, no, it was 15, x was 15.7, right?
But I'm saying 5.
So you have x equals 15.7. So then the year,
This is saying the year starting at 1990.
the year is going to equal 1995
Oh.
plus 15.7
Minus 5.
minus 5.
I don't know the reason.
So this is even worse than
Yeah. Which gives you 2005 plus a little bit.
Go ahead, you get it off?
Agreed?
That's funny, bro.
What does it say?
You get it off?
It says 1995, that the year that they're both, that they're equal is 1995 plus 15.7 minus 5. Which equals 2005. Plus, 2005 plus, because it's 2005.7, right? Here. Yes. Here. Okay? What's the next? You guys follow this? Good. What's the next part of this thing? What further information would you need in order to estimate the population of the crop-destroying insect once the arachnids have been introduced? What information would you need in order to estimate the population of the crop-destroying insect once the arachnids have been introduced? What would you need to know?
Basically, for the 100 mil. Like, how would you know?
Well, you would need to know the eating rate, the consumption rate, right? Do they tell you at what rate this thing consumes, the arachnid consumes the insect? No, you would need to know the consumption rate. Agreed?
Sir, can you explain the question?
Yeah. They're saying, look, all they told you is this. Shh. Sorry. They gave you the population of the insect versus time. Then after, from 1995 to whatever, 2011. Then afterwards they're like, in 1995 there's an arachnid, it eats this thing, and then they tell you how the arachnid's population grows. But they don't tell you about how quickly it eats the thing. They just tell you that it eats the thing, and then they tell you about its growth rate. But do they tell you a little bit about how quickly it eats?
So what we did in B was wrong.
No, what we did in B is right.
No, because because
Right.
it's gonna eat a little bit of those insects, but we didn't consider that.
But you didn't have to for part B. They didn't ask you to.
Yeah, I'm just saying that if you.
So to do part C,
Okay.
if you want to now know the effect of, because the population that they gave there initially is independent, right, of that, let's say. Independent of this insect. So if you want to do part C, then what you would need to know is, let's say, the consumption rate of one arachnid to consume, let's say, the rate at which one arachnid eats one insect, right? And then you'd have to, right? You'd have to know that rate, that consumption rate, but then you'd also have to take into account the fact that the population of the arachnid is changing too, right? Then you could actually know the rate at which the arachnid consumes the insect, right? As a function of time. You could use the time data to give you the consumption rate, and then you could take each of those population data and subtract that value from those to give you a new population which takes into account the kill rate. Does that make any sense?
Yeah.
To at least be
Our answer
that
in
would
the
be
back
cool,
is right.
actually. That would be a really cool question.
Our answer in the back is right. So.
Yeah, no, I know our answer in the back is right, but we're talking about, they don't give an answer to part
They
C.
do.
Oh, they do?
Yeah.
What do they say? Same thing?
It says the average number of the crop destroying insects that each arcanine will kill.
Yeah. Exactly. You could do it that way, you could do it, there are many
But the
ways.
thing is, when they eat one, can they eat another one?
Of course.
We don't know. That's, you'd have to invest, you'd have to get.
That means that you eat one and the whole life is the ratio is 1:1.
If you need
Could be.
to we don't know that.
But we don't know that.
If they give it to you, it's.
Write an expression for the size of this population. Up to you.
Didn't we do that?
We didn't write,
0.1.
we didn't, I just said it verbally. You're welcome to try.
Do you not gonna answer that?
What? I just did, I answered it verbally, now you can try writing it down mathematically. There are different ways you can do it. Okay, so are you guys clear on this one? Okay, oh, there's more. There's more. We have cause and effect, which is more qualitative information. Oh, we got to do critical analysis. And that's the end of it.
We still have until the 19th for
So let's talk about cause and effect. Can I share yours and then you guys can share? Thank you. Okay. Cause and effect relationship. Okay, cause and effect relationship I think is pretty self-explanatory. You want to know what the dependent variable is and what is the independent variable. Independent variable goes with the word cause, obviously, and effect goes with the word dependent variable. And they write that there, a change in x produces a change in y. That can be tricky to figure out sometimes. If we flip to page 196, they list a few things. Statistics can be complex when you're trying to look for something that there is no answer for yet. School is easier because they create questions and you can, even if you're stumped, compare to what a book's answer is. Guys, preet. So, if we take a look at common cause factors, they're trying to cite certain situations that are very relevant in trying to establish a cause and effect relationship, and one is a common cause factor. So what a common cause factor is all about is you may find, let's say you're examining the relationship between two variables, y and x, and maybe you find that, you know, when x goes up, y goes up. So you might say, oh, well, as I change x, y is clearly going up. Therefore, x is a cause and y is the effect. But it may turn out that there is some other variable, let's call it m, actually, let's call it, yeah, whatever. Doesn't matter what you call it. And it turns out that m is really the ultimate independent variable that makes x go up and also makes y go up. So it turns out that m is going up, and you're not aware of it necessarily, which is making x go up and making y go up. And so then you just establish a plot of y versus x, and you say, hey, y is going up because of x, but that's not true. Really, y was going up because of m, and x was going up because of m. So you thought that y was going up because of x. Agreed? In that case, m is what is called the common cause factor. And they give you a classic example, a simple, beautiful example. They say, suppose that a town finds that its revenue from parking fees at the beach each summer goes up with the local tomato harvest. It's true. If you go ahead and go in the summer in Ontario, let's say, and you plot, let's say, tomato harvest, the amount of tomatoes that you get from, let's say, August till end of September daily, and the amount of money you make, let's say, at the beach. Actually, it's a bad example because maybe it's flatlined already by August. But let's imagine that the tomatoes started growing in Toronto in June. So let's say you started seeing, oh, well, from June on in, you know, X is tomatoes, the number of tomatoes you get, they go up. And it turns out that Y is going to be the amount of money you make from parking at the beach, also goes up from June. So you're going to say, hey, if I want to make more money at the beach, I just need to plant more tomatoes, and then I'll generate more revenue. More people will come and park their cars at the beach. Of course, that's ridiculous, but it's very good because it illustrates the point they're trying to make, which is, of course, planting more tomatoes doesn't make more people park at the beach. What makes more people come to the beach is the weather. And what makes tomatoes grow is the weather. So the common cause factor, or what I chose to call here on the screen, M, is the weather. Okay? So Y is not dependent upon X in this case. Y is dependent upon M, positively so, and X is dependent upon M. Now, why do you think they want to point something like this out? Why would this be a smart thing to think about if you're doing statistical analysis?
Because you want to know what's the actual factor. You want to know what's...
Yeah.
Because it makes you think about more.
Yeah, it makes you think about more. It makes you be more careful. You might be doing some analysis which is complex, and you might say, oh my God, I found a relationship. When you increase this particular drug, as I bump up the concentration of this medication, of this tablet, I get a positive benefit to the patient. Therefore, that's what's doing it. But the body's a very complicated thing, right? The body doesn't operate, in isolation of just one variable. So it could be that there's something else that the patient is doing or receiving, which is actually responsible for them improving, right?
So you have to control every variable.
Sorry?
To control every variable.
You have to control every variable, or at the very least, you can't always control every variable. You have to be aware of the things as best as you can. And we'll be talking about other things like, for example, let's say this was the increase, you guys have heard of double-blinded studies versus blind studies? Okay, or let's just say blind studies versus non-blind, sorry, double-blinded. So a blind study might be if you are, let's say for example, what's a good way to say this? Let's say I have some kind of a disease, and my doctor says, look, there's this new experimental drug. It's not yet approved by the, in the States it's called Food and Drug Administration. What do they call it in Canada? Anybody know? No.
Maybe the CD.
Sorry?
I
don't know. So I'm sick and my doctor says, look, there's no medication yet made for you that's official or legal, but there's this study going on by between the government and Merck, which is a manufacturer of medications, and we'll let you be in the study. but it's going to be a blind study. What do they mean by that? Half of the patients are going to be getting a placebo, which is a sugar pill. It's going to be a pill, but there's not going to be anything in it but sugar. And half of the pills will actually have the medication. You won't know, you the patient will not know whether or not you've been given the placebo or you've been given the actual medication. Why? Why is that a benefit to the study?
So they don't know if the medicine is affecting them.
Because there could be a psychological effect, right? The mind is a very powerful thing. Very often we can feel better or believe we're feeling better because of something that we're receiving. So there would be M. If you take a look over here, the common cause factor in that particular case would be state of mind or optimism, right? You could have optimism. Well, yeah, your optimism is going up because you think you're getting the drug, let's say, right? So let's say the more of a drug you get, for example, the more your optimism goes up, and your optimism actually drives your health, and it turns out that it was optimism that was driving the health benefit, not the actual drug. So there's an example of why you would do a blind study. When again, that's called, and that would be, in that particular case, optimism would be the common cause. Sometimes they do a double-blind study where not only does the patient not know whether or not they're getting the medication, but also the doctor who's giving it to you doesn't know. Only the drug company knows. And why might that be a benefit? Why would they want to keep the doctor from knowing? Yes?
The doctor might have some element of bias, trying to get positive or negative.
Yeah, exactly. Maybe the doctor sees this little teensy bit of an improvement and somehow says, oh yeah, no, that's real improvement. Or maybe it was just noise. Right? We're all people, we're all influenced by, it's very hard for us to kind of ignore our, we have a tendency to want to see something. It's human nature.
The drug company wants to see positive too.
Yeah, but that's different. In this case, the drug company wants to know if the thing actually works.
Yeah, but they want it to be positive.
You're talking about, I know, you're talking about something else. You're talking about fraud. You're talking about, like...
No, like they want it to be positive, so they might get biased on the result.
But in this case, I'm talking about a situation where the drug company really wants to know if the drug works or not.
Okay.
So they don't want the... So the drug company is paying for the study. They give the medication to the doctor. The doctor administers it to his patient, his or her patient. But let's say they legitimately want to know if this thing works. They don't want they don't want the patient negative, like artificially inflating the result, the benefit, and the doctor could as well. Maybe the doctor is excited about the medication, right? On a subconscious level. Okay, so they want to remove as much bias as possible, even though it's unintentional. Okay, that's what Alexei's saying. And there's I showed kids last year. There's a great article from the New York Times that talks about research and this stuff. Oh shoot, what the hell is it called? It basically talks about how skewed the evidence of the fact that a lot of scientific research is skewed because the people who are doing the research want to see a positive result. And it's not in such an overt way, it's in very subtle ways. Because a lot of times the data that the margins of success or failure are so fine, just a little bit of subconscious bias can tilt the whole thing in one direction. Like there was something that said, like in some of the journals of medicine, or I forgot which journal, but of research, an overwhelmingly large percentage of the actual studies that are published are studies whereby the thing that they talk about is successful. And statistically, that doesn't make sense. Shouldn't it be about 50-50? Shouldn't 50% of stuff that you try maybe work and 50% don't work? Or maybe even less than 50% work? And yet, in a lot of these journals and magazines, 80% of what they publish works. Why? Because who the hell wants to talk about stuff that doesn't work? Boring. Anyhow, that's common cause. Reverse cause and effect. What would be an example of reverse cause and effect, whereby you think that, whereby you've decided that one thing is the independent variable, which is driving the dependent variable, but it turns out that it was the reverse. You were wrong. The dependent variable was the independent variable, and the independent variable was the dependent. Somebody want to come up with an example? I'll think too. Think of a situation where you're like, oh, I think this drives this, but it's really this that drives this.
I don't know if this will work, but like you could say that,
Put up your hand. Yeah.
you could say that like driving to this point, you can get there faster if you drive faster, right? But you could also say that you can get there faster if you're driving faster.
You just said the same thing.
You can get to a point earlier if you're driving faster, right?
Yeah.
But
Now
then
you said,
can
but
also
really,
say if you're driving faster,
you
get
can
to
get
this
there
point
earlier.
Yeah.
Yeah, you can get there earlier if you drive faster, but if you drive faster, you can get there earlier. Yeah, there earlier. If you drive faster, drive faster. My head hurts right now.
Yeah, let's check.
So I have a better example.
Yeah, but I would like one that's more, you can flip that both ways. I want one that definitively should go the other way, but yes.
So let's say bad marks will cause you stress, but actually the stress.
I like that. That makes more sense, right? Like maybe, right. That's a really good example. You think that it's your poor marks which are stressing you out, but in doing further research, they found out that person was stressed out and that's why they weren't performing. So in order to be able to figure out, but the thing is, in that situation, it could be either way, right? So what kind of things might you have to do to figure that out?
Let's see which one happened first. Did he start getting bad marks then stressed, or was he stressed out of the income?
That's one way, I think, yeah.
Knowing the personal issues of the person. So is everything okay at home, family, friends?
Makes sense, right? Other variables, other factors that may drive the stress independently of the marks. Smart, yeah.
Is this stress causing him to not be able to think straight on the exam?
Right, right. You can analyze that, right? Yes.
We often analyze if he was getting decent, or he or she was getting decent marks beforehand
Yes.
at a certain point.
Yes, absolutely. Okay, so that's good. So we understand this. What's an accidental relationship?
Completely accidental.
When X wasn't really supposed to make what a relationship.
Milad was nice one day.
Excuse the interruption, this announcement is for any grade 11 or 12 students who missed photo day. If they could go down for their retakes down in the library now. Thanks.
Milad was nice one day. And it turned out that Miss Cara Giorgio started chewing gum that day. So let's say, then I would go to Miss Cara Giorgio and I'd be like, listen, Miss Cara Giorgio, he was nicer, but he's still obnoxious. So could you just chew a little more gum? Just keep chewing more gum and then he'll be wonderful. And then Miss Cara Giorgio goes and starts chewing a lot of gum, but then the next day Milad is, I want to use a nice word. Or not use a non-nice word. Milad gets back to himself, and so clearly that was an accidental relationship, right? It was a fluke. It turned out that, it was a coincidence, right? It was a coincidental relationship. They call it accidental. It was simply a coincidence that she chewed gum that day, and Milad was just wonderful to his peers and his teacher and his family and his friends and his. I can't help it.
It's okay.
The best one was the day of the proof. Did we get Milad on tape that day?
No.
Do you remember the way he looked when he went up and did the proof? That attitude? Alexa remembers. It was great.
What?
It was the best face ever. He just went, this is it, man. 4 lights.
Is it on Facebook?
I don't have time for you people.
Facebook or music?
No, I don't think we got it. The engine's in. Okay, next one. Yeah.
A question about that. Does that only relate to one point or one incident, or can it relate for multiple days?
It could relate for multiple data points, but then I think you have to start to wonder then if you have common cause. But yeah, it could be for multiple data points for sure, right? So yeah, maybe it turned out Miss Cara Giorgio, yeah, whatever. Let's say she started chewing gum on Monday, and then she really liked that gum, so she was just chewing more. It wasn't because of stress or anything else, right? Well, actually, Yeah, we could say, you know what, it could even be because of stress. We could say that she started chewing more gum for that week, more and more stress. So the stress is what's affecting her chew rate, or her chew amount. And then Milad is just being nicer, I don't know, because of the weather or some other variable. So it's like you have, let's say, M, which is driving, you have M, which is driving, let's say, Ms. Kira Giorgio's chew rate, and then you have, let's say, maybe you have N, which is driving Milad being such a wonderful person.
Because of good mark.
And they have nothing to do with each other, N and M, right? So you have these two variables that are not connected, that are driving two different variables. And then you might say, oh, well, Y and X, Y is dependent on X. It's not true. It was N which was driving Y and M which was driving X. It's a coincidence. Last one here, presumed relationship. What is a presumed relationship? This is one of the trickiest ones. Anybody want to read it and tell me what that's all about? This is tricky. Yes.
So I think it's saying that there are two things that it seems logical that they are related, but you can't actually find a cause for it. It just seems logical.
So to me, a presumed relationship would be more like something that you would have to investigate further. Like it would be a project almost, right? Like, I don't know, people who drive fast tend to gamble a lot. Let's say that.
Watch F1.
Watch
F1.
What's Formula One? Well, that's going to be pretty easy. I think that one you'll find pretty fast. But yeah, that's not bad. Let's say people who drive quickly are gamblers. And let's say it turns out that there is a relationship there, some kind of relationship. People, the faster you drive, the more you gamble. I'm making this garbage up. Now, there seems to be something in that, like, oh, maybe you're a risk taker, so you drive faster, you're a risk taker, you gamble. Maybe. But that's a maybe, right? That's not a for sure. So you'd have to investigate further. So in that situation, there might be some logic behind that relationship, but it's not conclusive logic, right?
You can't prove it.
Yeah, maybe you can, but you need to do more work.
Like,
You can't prove it.
we usually say that there's something between the things, but we can't say it clearly.
Unless you go further, maybe you can dig deeper, right? So maybe in a scenario like that, I don't know, somehow you would find some kind of analysis which maybe you could find a common cause there, right? Like maybe you could show that people who like to take risks, maybe you could prove that somehow through some kind of experiment, like to drive faster, and then people who take risks tend to gamble. Maybe you could find something there, and then maybe you could prove that relationship. Okay, we don't have much more here. What are extraneous variables? Look at page 197. We talked about this. In the case of the blind study, if you don't make the study blind, what could be an extraneous variable that could drive the health of the person? Optimism, right? Well, the optimism would be the variable that would drive it. So that would be an extraneous variable, a variable that you didn't account for in the study. You're not tracing or tracking, but it really has an impact on the dependent variable. And then lastly, read the last paragraph of page 197. And I think that's going to be all we're going to do for today. Yes. On Monday.
No.
Didn't you say 19?
Yeah, Monday.
We have a test on Thursday.
Wait, next Monday?
Yeah.
Next Monday is not like.
What's next Monday?
12.
Well,
No, sir, please no.
Yes, sir.
Please, sir, no.
Sorry, you said
No, sir. No.
Okay. What is the point of an experimental group versus a control group?
we haven't read it.
So read it. This is very important too. Very important. Read it and then tell me what it's all about.
Oh, I get it.
Did you guys read it? Anybody want to explain what that's all about? Yes.
So it's saying that we have two groups. We call one of them experimental group and the other
Yeah,
one
we know
control
that.
group.
Yeah.
And then they are both affected by the external variable.
Extraneous?
Extraneous variable. And then we do the experiment for the experimental group and we don't do it for the control group. And the subtraction of those two will be our answer.
He's got it, but he didn't explain it well, but he's got it. Let's go back to the human being. Let's talk about again in a study where you're giving someone a drug to see if it'll make them better. Well, wellness is a function of so many things. I don't know, diet, mood, weather, relationships with others, and so on and so forth. So perhaps when they do this study, like we said, they do a blind study. Let's say they do 50% placebo, 50% actual drug. So that, and they try and choose people, let's say, for a similar age range, similar lifestyle, and so on and so forth, so that those other inherent factors that affect a person's wellness that are going to be there, whether they take the drug or not, are there. So let's say you see the wellness of a person kind of do this over that period without the drug. Presumably that if you're giving the drug to people who are similar, if you see the wellness go like that, as Milad said, you can subtract the wellness of the placebo from the wellness of the person actually getting the drug. Right? Because let's say maybe the weather's improving over the course of that span, and let's say there's a 5% increase in the quote-unquote wellness of the person that's not actually getting the drug. And then let's say with the drug there's a 20% increase in wellness. Well, it turns out that it's only 15%, right? To be crude about it, right? You want to subtract that extraneous wellness factor, right? Does that make sense?
Yep.
I think that's more than enough for today.
It's not like we have any more time.
We only have one more section, I believe. Is that right? 3.5? That's going to be it.
So what's the quiz?
Are we going to? Yeah, so we'll do the quiz on
Friday.
Friday. You want to do that? A short one. Mark, give it back.
Yeah.
Please move the test on Tuesday.
No.